Hello programmers, so we're going to have an introduction to CircuitPython on the CPB. We're going to print and then we'll light it up. And when we learn to light it up, we'll also learn about importing libraries, creating objects that are named with a variable. We'll learn how to perform actions on objects using methods. We'll learn about colors and RGB. And we'll also have some exercises too to turn the lights blue, purple, aqua, and orange. So let's get at it. Now I'd like you to type along with me, but there's also a written document that follows the steps that we're going to be performing, and you can find that in a Google Doc online at bit.ly/learn-circuitpython-on-cpb-part1. So feel free to refer to that just in case you're wondering, did I spell something right? Do I have a typo? But with that said, let's launch Moo and get at it. Now when you open up Moo for the very first time, you see that there's a tab that says Untitled. That means we're creating a new document. Now the line 1 has a pound sign there and it says write your code here. Now the pound sign is a comment character. It means ignore everything that comes after this character, don't execute it. It's a great way to document your program. So why don't we highlight the text after the pound, backspace over it, and write our first comment. So we'll write, this is my first program, dash, I don't need this line, just to remind us that we've got a comment here. Then press enter to move to the next line. Now the next thing that we're going to do is we're going to type in a print statement. It's all in lowercase, P-R-I-N-T. Now the yellow box that you see down here reminds you what this particular statement does. Sometimes it will be useful for us to refer to that, but right now we'll just go ahead and ignore it. Then we'll have an open parentheses and a close parentheses. Typically when we have a function to tell Python something to do, in this case we want to print something out, we'll do an open and close parenthesis, and then inside we'll put the stuff that that function needs. In this case, the text we want to print. The text to print goes in between a set of double quotes. I'm going to type in, I just wrote my first Python program, exclamation point. Now notice the tab says Untitled and there's an asterisk. The asterisk means we haven't saved anything yet, so I'm going to click on the Save button. We get a Save dialog box up here, and you want to save this file to your CircuitPy volume. If you don't see CircuitPy, make sure that you've plugged in your CPB. And it should show up and look just like a USB drive has been mounted to your computer. Now every time we save a file to the CPB, we're going to call it code.py. That's all in lowercase, and that's the name the CPB is going to be looking for the program that it should run. Click on Save. It'll only ask you to replace if you've already put a code.py file on there. And you don't see anything, but I want you to click on Serial. And what Serial does is it opens up a little window, and it shows you what's happening on your CPB. Now we're going to click the Save button one more time. That starts executing code.py right from the beginning. And whoa, it says, I just wrote my first Python program. And you did. Do a happy dance. Now let's modify some of that code. Highlight the word first, backspace over it, type the word second. Notice in the upper left-hand corner, code.py now has a little asterisk. That means you've made some modifications since the last time you clicked on Save. Let's click on Save. What happens is this saves it to the CPB. Runs the code right from the beginning, and whoa! We see another line show up here, and it says, I just wrote my second Python program. Nice work! Now every time you click on Save, you're saving code.py onto your CPB. But let's say you want to make a backup of your code and you want to save it on your computer. Well, what you can do is just double click on the tab that says code.py. That opens a standard save dialog box. Then you can go ahead and select your computer. I'm going to save to the desktop right here. I'm going to give the file a new name. I'm going to say my first Python program and click on save. And now I've got a version of this program saved onto my computer desktop. There's still code.py on my CPB, but I've got this backup copy too. So for my students, if I ever ask you to submit your challenge exercises, what you're going to do is double click on the tab, save the file to your computer using a name that you can recognize, and then you can turn that file in. Now here's something that's really important to understand. This file, it says my first print program.py. That's on our desktop of our computer. It's not on the CPB. So if we want to start executing code on our CPB, again, what we've got to do is double click on this tab. Then we've got to find our CircuitPy volume. If it's not showing, just click reset on your CPB. It should show up like a USB mounted device. Then click on CircuitPy. We'll name it code.py. We'll click on save, replace what's there. It's going to execute the code again because every time we save code.py on our CPB, it executes it again, so we see a little jump in the serial monitor down below, and it once again says, I just wrote my second Python program. Now what I want to do is I want you to highlight all of the text in our program. I want you to backspace over it, and then let's put a new comment in here. So pound sign, and then we'll say space, light it up. Then we're going to enter some lines of code. These 3 lines of code that we're going to enter are the 3 lines you'll need anytime you want to work with the 10 lights on your CPB. The first line is import board. Now Python itself doesn't know that the CPB exists, but when we say import board, what we're doing is we're importing a software library that extends Python and allows us to work with the board that we've just plugged into our computer. Now we're also going to say import NeoPixel. NeoPixel is the name for these little lights that can shine in any color, and so by importing that library, we're saying, hey, we're also going to work with lights in our program. Now the next line we type in is pixels space equals space. Now pixels is just the name we're going to use to refer to our lights. We could call our lights anything. We could give them the name Jennifer or Lady McLightface, but pixels is a pretty good name because the lights are called NeoPixels, and you'll see lots of example programs that use pixels to refer to the lights on the CPB. Now this name pixels is also what programmers call a variable. They call them variables because we can vary or make changes to whatever pixels is pointing to, and we'll see how we do that later on when we change the colors of the lights. Now after the equal sign we type in NeoPixel dot, and there's no space between NeoPixel and dot. That word NeoPixel is spelled the same way it is after import in the line import NeoPixel just above. And what we're saying here is we're saying, hey, go into that NeoPixel library that we just imported. Now the dot means look for a special command, and in this case we're going to use a command that allows us to set up our lights. The command to set up lights is capital N-E-O, capital P-I-X-E-L, NeoPixel. NeoPixel is followed by an open and close parenthesis, and just like our print statement, inside the parenthesis we're going to put in everything that needs to be used by this command NeoPixel. Now if you look at this statement, there are actually 4 parameters separated by 3 commas. The first thing is lowercase board dot all capital NeoPixel. That just says, hey, we are referring to the lights on our board. After the comma we have 10. That means there's 10 lights on the board. After that comma it says brightness equals 0.5. That means set the brightness of the lights to 50%. Then there's a comma and our last parameter, which is auto right equals true. There's an underscore between auto and right, and there's a capital in true. This just means if we ever make any changes to these lights called pixels, apply the changes right away. Now that's a gnarly bit of code, but here's the good thing. Whenever you want to work with lights on your circuit playground Bluefruit, just copy these 3 lines of code, paste them into your code, you can reuse them over and over again, and as long as you're setting things up the same way, you can just use this almost like a software Lego. So here I am in Moo, and I'm going to type in exactly what I had in the previous slides. Import space board, import space NeoPixel. I'll give myself another line for space in here. I'll say pixels equals NeoPixel dot NeoPixel, then type open parenthesis, and then I'll type in my 4 parameters. It's board.neopixel, comma 10 for 10 lights, comma brightness equals 0.5 for 50%, and then comma auto underscore right equals capital T and true, and then close with parenthesis in here. Now here's a very important thing about Python. It's super particular about capitalization, spaces, indentation, and if Python ever expects things to look a particular way and it's not set up that way, your code won't work. So you want to take a look at these lines and make sure that your capitalization is all matched up, that your spaces are all matched up, that you don't have any extra spaces or you're not missing any spaces. Any open parentheses also have a matching close parenthesis at the end. And once you've got that, then you're in good shape. So these first 3 lines, all about the setup. To get the lights to do something, we're just going to type in this line. And this line says, hey, go into those lights that we just referred to as pixels, all 10 of them, and fill them with a color. The pixels part here says, hey, those are our 10 lights. The dot fill part is a special command. Programmers call this a method, and this method means fill in the lights with a particular color. Inside the parentheses, we see another set of parentheses with 3 numbers. Those 3 numbers represent red, green, and blue. And by mixing the colors red, green, and blue, we can produce just about any color in the spectrum. So no color is 0. 255 means as much of that color as possible. So what we're showing here is since the first value is red, 255 means fully red. 0 and 0 means nothing for green and nothing for blue. So when we press on the save button after typing this line, this code is going to execute. All 10 lights are going to be filled with the color red. So now let's type in that line, pixels.fill, open and close parenthesis, and then inside we put in a color, which is expressed by another open and close parenthesis, and for red we'll do 255, full on red, comma 0, no green, comma 0, no blue. We'll go up here, click on the save button, take a look at your CPX, and boom, all the lights show up in red. Fantastic! Now that you got this working, let's try a few challenge problems. The first thing we want to do is light the CPXB up with all blue lights. So why don't you pause, give this a shot, and now unpause. Let's see, did you get it right? What we should do is just change that color to 0, 0, 255. That means no red, no green, full-on blue. Here's another challenge problem. How do we light up the CPB with all purple lights? Pause. And come back. So hopefully you got pixels.fill, and then inside we've got 255, 0, 255. Full on red, full on blue, no green gives us this nice purple. Now here's our last challenge. Why don't we search online for RGB colors and see if you can figure out how to set the lights to orange, and then how you could set them to aqua. Pause. And we're back. Now in Google, you can type in something simple like RGB colors. You see one of the first links up here says RGB color codes chart. If we click on this, we see a bunch of different colors. If I hover my cursor right over this one that looks a little orange, we can see down below the values for that orange are 255, 128, and 0. So we can try that out. Now that looks a little yellowish to me, but what you can do is you can tweak these numbers to try to come up with the right color that you're expecting. So I'm going to say 255, 64, 0. Boom, that looks much more orange. Now what about aqua? What I'm going to do is I'm going to type in RGB aqua right into Google. I'm going to click on this first link. I'm going to see the numbers that it gives me. I see 146, 211, 202. I'm going to type those in and click on save, and it looks pretty white. But what you can do is you can play around with those numbers, and why don't you try to do that right now to see if you can come up with some aqua on your own. So we had some big learning in here. We learned about the print command. We learned how to save backup copies of our program to our computer. We did some lighted up exercises where we imported libraries. We learned how to create objects named with a variable. We performed actions on the objects using methods, specifically the fill method. We learned about colors and RGB. Hope you're feeling good about your Python skills. Keep at it.